Hello viewers, welcome to my YouTube channel. If it's your first time coming across it, try to subscribe, share the videos, and leave a comment on it. So today we are going to look at units and measurement. Specifically, we are talking about physics. So under units and measurements, we have to know a good number of things that are going to help us proceed in our calculations. So if we try to look into details of this, we have to concentrate on what physical quantities are, and those are what we call the basics of units and measurements. So we have to know what a physical quantity is. Apart from that, if you are able to understand what physical quantities are, you must know how to do some sorts of conversions. And probably our today's discussion, we have to concentrate on what conversions are all about. But you can't know what to do on conversions minus knowing what physical quantities are. So in simple terms, if you want to define what a physical quantity is, you understand that a physical quantity has to be a quantity that can be measured and be expressed in a form of units. All right. So basically, we have 7 basic physical quantities. We have 7 basic physical quantities. In other ways, the same 7 basic physical quantities that are called fundamental quantities. And what are these same 7 physical quantities that we are talking about? Get back a bit to what a physical quantity is. We are saying everything that can be measured and expressed in a form of units, that is what we call a physical quantity. Now take it in an easy way, whereby you want to know what the same units are all about. So if we are trying to talk about the units for every physical quantity here, we simply mean the approved physical quantities, those international approved units for every physical quantity that is just explained here. So you understand that if you try to look into the details of what are the basic SI units for mass, time, length, temperature, electric current, amount of substance, and light intensity, everything here has got its own SI units. And what are these same SI units? If you talk of SI units, in other ways, you can say the base units. Why? Because they are independent of the other. So in short, all these quantities we are able to see here, they are independent of the other. They just stand on their own. Meaning that even itself, everything here must have its own SI units. So what is the same SI unit we're trying to talk about? If we talk about SI units, we simply mean the standard international units that are acceptable for every physical quantity that is just here. So if we try to analyze what are the SI units for mass, you understand that the best SI units for mass are supposed to be what? So what we are going to understand from here is that these 7 basic physical quantities, they can also be combined. And what name is given to a quantity which involves the combination of 2 or more physical quantities? That is what we call a derived quantity. That is what we call a derived quantity. A good example, we can have velocity. You understand that velocity is made up of meters and seconds. So it involves 2 different physical quantities that are just mixed or that are just combined in such a manner. Now, let's try to go into what conversions are all about, because that's what we are going to discuss on today as our main area of concern. So if you try to go into the discussion of conversions, we are going to understand that conversions are categorized into 2. Conversions are categorized into 2. Let me try to write conversions here. We try to write conversions. Let's try to write conversions somewhere there. I'll do this. Right. So conversions are categorized into 2. We are going to be dealing with conversions that just involves converting a certain unit into the other unit, and also it involves converting the same unit but different in what? Some differences in terms of how you can express using some other prefixes that we can add before or after. So before we go into details of what conversions are all about, we must know that most of the times these same conversions, they involve a certain class of conversions, that is what we call prefixes. They involve a certain class of conversion, that is what we call a prefix. And what are these same prefixes? We are going to understand that we have a lot of prefixes. Probably they are categorized into two. We have prefixes that denote the decrease in the number of the same units you've been given. We also have prefixes that involves an increase in the number of the quantities you've been given. I'll start with those that involves the decrease in number of the quantities you've been given. So let me try to divide this into the middle of itself. So we are going to understand that if you start with those that involves an increase or decrease in the number of the quantity you are trying to deal with, we can start with the one which is this. We have cent. We also have milli. We have micro. Nano. We also have pico, until you go down. But you understand that most of the times, always, the best prefixes that we normally use ends from here. These are the most used prefixes. And what's the meaning of this? What is the meaning of cent? What is the meaning of milli? And so on. So these are not SI units. These are not SI units. Why? Because they just help you write something which is very, very big into these quantities. These prefixes, which is going to decrease the same number of that specific physical quantity, or rather maybe SI units. So if we talk of this actually simply means this has to be 10 to the power -1. Cent has to be something which is going to be 10 to the power -2. Then milli has to be something which is going to be 10 to the power -3. And micro has to be something which is going to be 10 to the power -6. And nano has to be 10 to the power -9, and pico has to be 10 to the power -12. Remember, I repeat, I'm saying these are not SI units. Nano, cent, you can put these same conversions or rather prefixes for every quantity that you are we are from writing somewhere there. So you understand that you can have, if you want to write maybe meters, meter, we understand that we can have millimeter. Why? Because you are trying to express meters in terms of what? Millimeter. Suppose you want to write 1 millimeter. What are we supposed to do in terms of meters? So what we are going to understand here the most is, for you to easily remember to say, okay, a single millimeter has to be written like this. Check, we have millimeter. What's the meaning of milli? You write the meaning of milli, which is what? 10 to the power -3. Then if you talk of meter, you just get the same meter and you write it in front of what? This as a standard number given. So we are going to write something like this, meaning that a single millimeter can just be the same as what? 10 to the power -3 meters. If we want to write this in a proper way, how can you write the number which is raised to power of 3? How can you write the number which is just raised to power of 3? So what we are going to understand here is this. If you have a single millimeter, you equate it to something like this. We understand that if you have 2 to the power -1, this is just 1 and the same as 1/2, something like that. Same applies to this one. How can you write this? You can also write this as 1/10 to the power 3. You put a meter somewhere there. Do some simple mathematics here. You understand that a meter and 1, they are going to be multiplied. Then 10 to the power 3, it can also be multiplied by what? 1 millimeter. So what we are going to understand, if you have 10 to the power 3, this is just one and the same like 1000. Hence, in other ways, you can also write this number as 1 over 1000 meters. So what we are going to do is this. We have to write a single millimeter and equate it to what? To m, or that is a single meter divided by what? 1000. Then you understand that if you multiply, you do some multiplications. Do this and that, we can multiply and we'll end up having something which is going to be what? A single meter in other ways can just be the same as 1000 millimeter. When doing some conversions, when it comes to the issue of doing some conversions, we normally use the same scenario. But here, if you want to do the same to my conversions, we use a certain process which is called a chain link method. That process has to be called a chain link method, meaning that the number which is here can be written in two different ways. It can either be written as 1000 millimeters per meter, or you can put meters on top, you divide by 1000. This actually depends on what you are trying to do when it comes to conversions. Apart from these numbers that involves a decrease in the conversions, we can also have a certain class of what we call the prefixes that we can use. We can have the first one here, which is deca. We can also have what we call hectare. We can also have kilo. We can also have giga. We can also have sorry. We start with mega instead of giga. I'm going to have mega. We can also have giga. We're going to have tera. You go down as we're trying to increase in the number of powers. So what we are going to understand is deca. This one has to be 10 to the power 1. Remember, deca is not an SI unit, meaning that it can stand for every SI unit based on the 7 basic or fundamental quantities. Hectare has to be something like 10 to the power 2. Then kilo, we are going to have 10 to the power 3. Mega, we are going to have 10 to the power 6. Giga, we are going to have 10 to the power. We're going to have 10 to the power 9. Then tera, we're going to have 10 to the power 12. This actually can give us a simple example. For instance, we want to write a single kilometer. Just check back. What is kilo? We understand that kilo has to be something which is raised to power of what? 3. I'll write it here. 10 to the power 3. This is the best way you can remember how to do this to my conversions. Kilo, you write what it is equal to. Then meter, you just get this thing and write it somewhere here. Meaning that a single kilometer has to be equated to what? 10 to the power 3, which is just one and the same as a single kilometer has to be equal to what? 1000 meters. If you are dealing with conversions using a chain link, you can write these two numbers like this. You're going to write it like 1000 meters at a given kilometer, or in other ways, you can also write a single kilometer at a given 1000 meters. A given 1000 meters. All right. We also have a certain class of conversion which involves the system of converting. Maybe you want to convert liters into milliliters, something like that. What are you supposed to do if you want to do such type of conversions? So what we are going to understand is this. Suppose you want to do some conversions involving meters. In a simple way, a single liter has to be equal to what? A single liter can just be the same as 10 or maybe 1000 milliliters. Do you know the reason why we are saying a single liter has to be equal to something like this? It's because if you get back a bit to milli, we understand that you can express a single milliliter by dividing throughout by 1000. Even here, by 1000. You do this, meaning that a single milliliter has to be something which is going to be 1 over 1000, then you put a liter somewhere there. So if you want to write this using powers now, you find that this can just be the same as a single milliliter has to be equal to 1 over 10 to the power 3 liters. Then express this in a form of what? Powers, by taking this on top, meaning that a single milliliter has to be equal to what? 10 to the power negative 3 liter. So 1 liter can just be the same as what? 1000 milliliters. In other words, a single liter can also be the same as 1000 cubic centimeters. Then a chain has to go like this. We are going to have a single liter which is going to be equal to 1000 milliliter. It can also be equated to 1000 cubic centimeters. At this instant, what we are going to understand is if a single liter is equal to this and also a single liter is equal to that, meaning that even the last two are supposed to be equated. Hence, if you equate 1000 milliliters to 1000 cubic centimeters, this will bring you to something like a single milliliter has to be equal to what? A single cubic centimeter. Suppose you want to convert maybe you want to convert something from a single cubic centimeters into meter cubed. What are you supposed to do? Still here we have to use what we call a chain link. Now the question is, how do you use the same chain link? How do you use that same chain link? For you to use a chain link, it has to be something which is very, very simple. When using a chain link, you have to maintain the conversions that are supposed to be cancelled out. You have to maintain the conversions that are supposed to be cancelled out. Suppose you want to express this one in a form of maybe cubic meters, or maybe I would like to put it like this. I want to convert 1 meter into centimeters. Avoid the system of saying 1 meter is equal to 100 centimeters. You have to avoid something like this. You need to avoid something like this. Why? Because we are interested in using what we call a chain link. All right. Okay. For instance, I would like to put an example here. Suppose you want to convert, let's say maybe I'll say convert 2 meters into centimeters. I want to explain something on how a chain link works. So you have to take this number, you write it down here, 2 meters. Then you must multiply. You have to multiply by something which is like an over. So what are you supposed to do? Remember, I want to get rid of the meter which is here so that I can convert it into what? Meters. Meaning that the quantity which is here must be a denominator after multiplying by over. I'll put a meter somewhere here. Remember, you want to convert into centimeters. What are you supposed to do? I'll put centimeters on top. Now the thing is, you have to concentrate on how many centimeters makes up a single meter. Why are we doing it like this? Is because we want to convert this one into centimeters. So how many centimeters makes up a meter? We are going to understand that we have 100 centimeters that are going to make up what? A centimeter. I'll put 100 here. So since I have a centimeter already on top, meaning that no need of me again including a centimeter after writing 100. So you find that this and that they're going to be cancelled. This is the only trick part where you have to concentrate on. So if you cancel this and that, then you have a 2 and 100 centimeter remaining. The moment you multiply a 2 and 100 centimeter, because here you're going to have a 1 somewhere there, you also have a 1. 1 multiplied by 2, that's why we remain with a 2. Then multiply 2 by 100, you'll be able to get 200 centimeters. And that's how we use a chain link. That's how we use what we call a chain link. Suppose you want to convert 2 cubic centimeters into cubic meters. Suppose you want to convert 2 cubic centimeters into cubic meters. What actually are you supposed to do? What actually are you supposed do. All right, I would like to convert 2 cubic centimeters into cubic meters. The conversions we are going to take are supposed to be like the way we are doing whenever we want to convert centimeters into meters. Still more, I'm going to write 2 cubic centimeters. I'll put a multiplication sign here, then you write an overlay. You put centimeters down. Then you have to concentrate now on what you've been asked. Remember, we are trying to convert. First of all, know that you have to convert from centimeters to meters before you think of cubic meter, something like that. Yes, we understand that this one is having a cubic meter, but we have to know how are we going to arrange the same conversions. Remember, we are trying to convert a certain system of length from centimeters into what? Into meters. Then the thing is, we have a meter on top. Get back a bit to what we are from doing somewhere there. We said how many. Now what you're going to do, you say how many centimeters makes up a single meter. What you are going to understand is we have 100 centimeters making up what? A single meter. If the centimeter which is located here is cubed, meaning that what we are going to do to both of these two quantities, or rather the units, we have to raise them to power of 3 also as a whole. You do this, then this has to be raised to power of 3 also. So we are going to have 2 cubic centimeters multiplied by, remember this has to be both on the part of this, it has to be on the part of that, and also 100. Why? Because there is a multiplication between 100 and centimeters. So if you make the whole lot of the down part be raised to power of 3, meaning that 100 has to be raised to power of 3, and also centimeter has to be raised to power of 3. So we are going to have cubic meter on top, divide by, then 100 has to be raised to power of 3, including centimeters. You must also make them be raised to power of 3. This is to make sure that the cubic centimeter on this part and that one must be cancelled. Then your answer now has to be 2 multiplied by a cubic meter. You divide this by 100 to the power 3. The same process has to take place if you want to change. Maybe suppose this was 2 cubic meter into cubic centimeters. So here you punch on your calculator. If you plug this into your calculator, you find that we are going to have something like this divided by like that. Then you can plug this into your calculator. Suppose you want to convert maybe 2 cubic meters into cubic centimeters. How will the arrangement be? We are going to write this at the beginning. You put 2 cubic meters, you multiply this by, then you put an over. So you have to make sure that you want to get rid of this, meaning that always this must have a similar unit down here. Why? Because the moment you multiply this by the top part, this and what is on top, they're going to be cancelled. All right, so we want to put centimeters on top. The conversion has to go like this. You are trying to convert from this going to that. So how many centimeters makes up meters? Remember, we just because you have a prefix of cent, we said cent has to be equated to what? 10 to the power negative 3. When doing conversions, we don't write the power negative 3 again, no. Why? Because this is just one and the same as you are writing centimeter. Cent has to stand on the part of this. Then meter, just take a meter, you put it in front. That's why we are saying a single centimeter has to be equal to what? 10 to the power negative 3. So cent has to be for 10 to the power negative 3. Then meter, you just write it here. Writing this in a proper, to the power negative 2. Writing this in a proper order, you understand that we are going to have a single meter has to be equated to what? 100 centimeters. Same applies even here. You understand that how many centimeters makes up a single meter? We are going to have 100 centimeters. All right, so since we have a cube on top, meaning that whole lot of this part, you have to raise it to power of 3 also. And definitely we are going to have 2 cubic centimeters, multiply this by, make sure that this power has to be on part of 100 and centimeter. We are going to have 100 cubed then centimeter has to be raised to power of 3 also. Even the meter down has to be raised to power of 3. This is to make sure that this and that has to be cancelled. We are going to have 2 by 100 to the power 3 centimeter cubed. And you punch that on your calculator, you'll be able to get the answer. You punch that on your calculator, you'll definitely be able to get an answer. Now the question is, suppose you want to convert a certain system of conversions. Suppose you want to convert a certain system of conversions. All right, let me try to have examples here. Convert 72 kilometers per hour into meters per second They won't tell you to say, can you use a chain link? What should always come into your mind has to be a chain link. And how do you link up the same conversions, or rather the SI units? You have to convert a single unit by a single unit. So from here, the way I'm going to write my 72, say solutions, I'll try to write my 72 kilometers per hour like this. Then I can start by converting a kilometer into hours. Into meters, sorry. Remember, we are trying to have a meter per second, meaning that a kilometer has to be converted into meters, and second has to be converted, and hour has to be converted into seconds. So what we are going to do, I'll do like this. I'll multiply, I'll put an over somewhere here. Then since I'm interested in converting this, first of all, where are you supposed to put this? Is it on top or down? So since you want to convert this one, you have to put kilometers down, you write meters on top. Why? Because if you write kilometer here, it has to be cancelled by what is somewhere there. Then I'll write meters. Remember, there is only one thing which makes up the other. In this case, we're trying to talk about meters. How many meters makes up a kilometer? How many meters makes up a kilometer? We have 1000 meters. Then you write it like that, meaning that we are going to have 1000 meters makes up a kilometer. It's more like you're saying a single kilometer has to be equated to what? To 1000 meters. If you write the same conversions that are here in terms of a fraction, we are going to understand that you can either divide throughout by kilometer, even here by kilometer, to make a fraction like this based on what you want to convert. If you were asked to say, can you convert the meters into kilometers, I would have put kilometers on top, meters down, so that the meters you've been given in the question and what you're writing down, they have to be cancelled. Then if we continue, we are going to find that we're going to have 72 kilometers per hour. You multiply this by 1000 meters at a given kilometer. Now you are interested in converting what we call the hour into seconds. You convert an hour into seconds. So the best way of converting hours to seconds, you must know first of all how to convert hours into minutes, minutes into seconds now. So I'll start by converting an hour into what? Into minutes. I'll do this. I'll also put an over. Since I'm interested in making this disappear, I have to put it on top so that this and that should be cancelled in our calculations. Then you write minutes down here. Then the question is, which one makes up the other between the two? Is it minutes or maybe hours? So you understand that minutes are the ones that makes up an hour. And how many minutes makes up an hour? We are having 60 minutes. All right, we are done. But remember, our goal is to make sure that we reach up to seconds, meaning that you must also convert minutes into what? Into seconds. I'll put a multiplication sign here. I'll do this also. Then you have to make sure that this disappears. And how can you make this one disappear? You must put it on top. You say a single minute. So you have to write now seconds down here. Why are we trying to write it like this? It's because if you try to take it seriously, you understand that this and that would disappear, this and that would disappear, this and that would disappear. Then you have meters and seconds only remaining. That is going to be expressed in a form of what? Meters per second. So how many or which one between the two makes up the other? Probably we are talking about seconds. How many seconds makes up a minute? We are going to have 60 seconds. Then you start cancelling out what is common in this same expression. So we have this and that will disappear. This and that will go. A kilometer and a kilometer will go. Then try to multiply the top parts. You try to multiply the numerator and also do the same to the denominators. So the moment you do some multiplications on the part of the numerator, you understand that we are going to have 72 multiplied by 1000 meters. This has to give us 7200 meters. You divide. You come down here, if you try to multiply 60 by 60, you try to multiply 60 by 60, we are getting 3600 seconds. We are getting 3600 seconds. You can cancel this. You can also cancel those. So if you try to divide 36 into 720 meters, definitely I think we have to get 20 meters per second. Why? Because this can go into 72, but it can't go in 0, and it has to give you something like a 0. This is how we use, or this is how you convert what we call, or this is how you use what we call a chain link method. Last example that I would like to give has to go like this. The last example that I'm going to give has to go like this. All right, we proceed. I'll say grams. B, I'll say milligrams. And the last one, I'll say micrograms. We proceed. All right, so our solutions. Okay, our solutions: avoid the system of converting using a primary way of doing things. So you have to be concentrating on what we call a chain link. We have to concentrate on what we call a chain link. All right, so if we try to proceed, what we are going to understand is this. I'm saying like avoid the system of converting this using primary way of conversions. So still you have to get this, and it is very, very simple for you to convert the number which is just given there. We start with A. If you have 5 multiplied by 10 to the power negative 6, that is kilograms, and yet you want to convert it into grams, what are you supposed to do? You put an over. Look at what you have here. To make this disappear and get the other unit, you have to put this down here. I'll put a kg down. Then after putting a kg down, you must put the ones that you want to get. The needed unit, you put it on top. Then the thing is, which one between the two makes up the other? You understand that grams are the ones that makes up a kilogram. The meaning of kilo simply means 10 to the power 3. Then gram, it has to come from somewhere there. So what we are going to understand is this. You write 1000 grams makes up a kilogram. Then this and that must disappear. It has to disappear, and we are going to get the resulting answer at the end of the hour. So if you try to multiply, you can just do this. You write exponential, then you say negative 6. You understand that the exponential is the one which is already having multiplied by 10. Then you put a power, it will give you something like that. So if you try to multiply this by 1000, we are going to have an answer as 5 to the power negative 3 grams. the answer has to be, we're going to get our resulting answer as, 5 multiplied by 10 to the power negative 3 grams. This has to be the resulting answer. This has to be a resulting answer. All right, we try to proceed. You want to get into milligrams. How do you convert a kg into milligrams? How do you convert a kg into milligrams? For B, remember, we are interested in converting 5 multiplied by 10 to the power negative 6 kg into milligrams. There is something behind. Remember, you can even start from here. You can even start from somewhere there. You can take it from here, you can take it from there, still the answer is going to be the same. Why? Because this is saying milligrams. It is saying milligrams, meaning that you must convert this one first into grams. After grams, that's when now you convert into milligrams. Let me try to take it from where we are. That is 5 multiplied by 10 to the power negative 3 grams. Remember, we are saying milli has to be something which is equal to 10 to the power negative 3. In a case whereby they're saying milligram, what are we supposed to do? Get what a milli is, 10 to the power negative 3, and get a gram and put it somewhere here. Meaning that a single milligram has to be equated to 10 to the power negative 3. And how can you write this in a proper way if you want to write in form of a gram? It has to give you something like a single gram has to be equated to 1000, or rather 10 to the power 3 milligrams. So this expression, you can use this depending on what you've been given. Either you make gram be down or milligram, it will be down. Meaning that we can have 1000 milligrams per gram. That is depending on what you have been given. If you want to get rid of maybe grams, blah, 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 blah. Or in other ways, you can make it like a single gram divided by 1000 milligram. So we apply this if you want to get milligrams. Why? Because a gram and what you've been given in a question as a gram, they're going to be cancelled. And also we apply this in a case whereby you want to convert a milligram into grams. Get back a bit to this. Which one between the two are we supposed to use? Is it this one or maybe that one? All right, we have to use this one. Why? Because it helps you convert a gram into milligram by converting this or by cancelling this and what you have somewhere there. We are going to have something like this. Gram, you make a multiplication, you put an over, then you write gram down here, you write milligram. Try to check which quantity makes up the other, or which unit makes up the other. You understand that milligram is the one which makes up what? A gram. And you have to put it somewhere here. You write it on top. 1000 milligrams is supposed to make a single gram. Then this and that are going to be what? Are going to be cancelled. And your answer now that you're going to get has to be 5 multiplied by 10 to the power 3 by 1000. Definitely the final answer has to be 5 grams. The final answer has to be 5 grams. All right. We go to question number, the same question. Now you go to C. You go to C. Okay, so we are going to have a C here whereby they're saying micrograms. You can still take it from here. It's okay. You can take it from where? From a gram. Why? Because we are interested in making this into micrograms. Remember, the symbol that you can use for microgram has to be something like this. Then you write like that. That's what we call a microgram, the one which is just located somewhere there. That's what we call micro. So you put micro in terms of whatever units you are trying to deal with. So if you have 5 multiplied by 10 to the power negative 3 grams, what are you supposed to do? Definitely, what are you supposed to do? You need to understand that you have to put something like this. You put an over. Then don't forget to write a gram down here. Why? Because you want to get rid of it. And what have you been given, or what have you been asked in the question? They're saying we have to convert a gram into micrograms. I still remember I said micro. micro, this one, it has to be equated to 10 to the power negative 6. So if you're dealing with microgram, meaning that it has to be what? 10 to the power 6, to the power negative 6 grams. Writing this in a proper way whereby you want to get a gram, it's just one and the same, like a single gram has to be equated to what? 10 to the power 6 micrograms. Where is this coming from? Make this in a form of a fraction. Why? Because it has a power of negative 1. Negative 6, sorry. Meaning that we can have 1 over 10 to the power 6 gram, equate this to microgram. This and what is here, they're just one and the same things. So multiply this by that, this by what is on the part or the numerator, you get something like this. Meaning that even the conversions we are going to have here, you must put microgram on top. How many micrograms makes up a single gram? We are going to have something like 10 to the power 6 micrograms makes up a single gram. Then if you do some multiplications, you try to do some multiplications like this, you have something like that, you multiply it by 10 to the power of 6, and definitely your answer has to be 5,000 micrograms. So you cancel this, you cancel that, you remain with micrograms, and the answer you're going to get now has to be 5,000 micrograms. If we were to do it up to nano, you'll find that how many nanograms makes up a single gram. It has to be something like a single gram can also be equated to 10 to the power 9 nanogram. So you write this. If you want to involve the system of conversions, you can also write this, but avoid putting 10 to the power negative 6 because it is meant for grams. A single microgram, it has to be equated to this. Now you want to get a gram. What are you supposed to do? You do this to my calculations until you reach somewhere there. So this is all what I wanted to show you, people. Subscribe to the channel, try to share the videos as we are trying to wait for more videos on the part of conversions. Thank you.